In this video, we've come to our first theorem, and it's the properties of vector operations. So essentially, if you look at these different properties, every single property that you would expect to work from algebra actually does work. So the commutative property is just fine. So we've got three vectors, u, v, and w. U plus v is going to be the same thing as v plus u. There's going to be no problems with that. And as an example, let's let u equal 1, 4, and let v equal 2, 3. Well, u plus v is equal to 1 plus 2. Those are my x values. And then my y values are 4 plus 3. So this equals 3, 7. Similarly, v plus u is equal to, or v goes first here, so this is going to be 2 plus 1, and 3 plus 4, getting us the exact same 3 and 7. Again, that was using the operation properties that we had for component form from the previous video. And the associative property is going to work as well. Excuse me. Doesn't matter the order with which we add, because again, we're adding component-wise, so it's going to be all of the same values and all the same properties that algebra is going to have. 0 is going to be our identity. So if we're adding 0 to a vector, we're not changing anything. This property here. The additive inverse will work. So if we have, so u is 1, 4. Let's change this here. U is 1, 4. If we let, we have negative u is going to equal -1, -4. So if we take u plus a negative u, that's going to equal 1 plus a -1, and then 4 plus a -4, which will give us 0, 0, which is the 0 vector. And that was this property, the additive inverse property. Scalar multiplication is not going to change. If you recall, component-wise, let's just make a scalar be 2. Let's see, 2 and 3. Let's make r. Set r equal 2 and s equal 3. We've got our u there. R times SU. I'm just going to do that for clarification's sake. This is going to equal 2 times 3u. That equals 2, and u again is 1/4, so that's going to be 3/12. We multiply the 2 through, and that gives us a 6 and 24. Similarly, if I take RS and multiply them together, this equals 2 times 3 multiplied by our vector, which is 6 multiplied by our vector, which is then 6 times 1, which is 6, and 6 times 4, which is 24. So again, that one is going to work as well. That's this one here. 2 times 3 multiplied by our vector, which is 6 multiplied by our vector, which is 6, and 6 times 4, which is 24. So again, that one is going to work as well. That's this one here. 2 times 3 multiplied by our vector, which is 6 multiplied by our vector, which is 6, and 6 times 4, which is 24. So again, that one is going to work as well. That's this one here. And the other properties work just the same. I'll save that as an exercise if you want to practice with some of these problems. But the distributive property works right or left. Basically, if we're adding up the vectors and then multiplying by a scalar, we're going to have the same thing as if we are, and that's this one here. We add up the vectors, we can distribute that r through them. And the above distributive property works. And then the identity of 1 isn't going to change any vector because we're multiplying each component by 1, which doesn't change the components at all. And multiplying by the scalar of 0 will certainly nullify it because 0 times each component will be 0, 0, and so forth. So that's a summary of this theorem. And again, all of the algebraic properties work for vectors, again, as you would assume that they would.